In this question, we are given three curves. The first curve is x square plus y square is equal to 16. The second curve is equal to x square plus y square minus 12x minus 16y plus 84 is equal to 0. Both of them are circles. And the third curve is essentially a straight line which is equal to 2x minus y is equal to 5 root 5. Before we actually solve this question, let us simply revise the equation of a circle. The equation of a circle is of the form x minus a whole square plus y minus b whole square is equal to r square. The center of the circle is a comma b and the radius is equal to r. So the first curve x square plus y square is equal to 16. This is, if you are calling this C1, the center is 0 comma 0 which is the origin and the radius is equal to 4 which is the square root of 16. For the second curve, x square plus y square minus 12x minus 16y plus 84 is equal to 0 can be transformed to equal the following. This is of the form x minus 6 whole square because you want to combine x square minus 12x plus 36 plus y minus 8 whole square because you want to compare y square minus 16y plus 64. If you are combining these two, you are going to get 100. Over here you have only 84, so you need to add 16 to both sides. So essentially this becomes equal to 16. So the second curve, this can be just transformed to the form x minus 6 whole square plus y minus 8 whole square is equal to 16. So the second curve is also a circle. The center of the circle is 6 comma 8 and the radius is also equal to 4. Now if you are given a point and a straight line, let us assume that the straight line is ax plus by plus c is equal to 0 and let the point be equal to x1 comma y1. What is the distance between the point and the straight line? That is equal to modulus of ax1 plus by1 plus c divided by square root of a square plus b square. In this particular question, we are asked to find out the minimum distance between the circle and the straight line. So now there are some cases possible. If you have a circle like this, the straight line can be passing outside the circle. In that case, the minimum distance will be when you draw a perpendicular from the center of the circle to the straight line. Let the radius of the circle be r and let the distance be equal to l. Then the minimum distance of the circle from the straight line will be equal to L minus R. But in the case where the straight line is actually intersecting the circle, in that case you are going to get that the distance L from the center to the straight line will be less than R. So the line is actually intersecting the circle, so the minimum distance between the circle and the line will be 0 because there are 2 points of intersection. At least 2 points of intersection. If basically L is less than R, there will be 2 points of intersection. If L is equal to R, then that line is a tangent. So you shouldn't say that there are at least 2 points of intersection. If L, that is the distance from the center to the straight line, is equal to R, then this line is a tangent. If L is less than R, then this line is intersecting the circle. If L is greater than R, then this line is lying somewhere outside the circle. And so the minimum distance is L minus R. These are the 3 cases that are possible. Now that we know this background, let us try to answer this particular question. In this particular question, the distance between the first circle and the straight line, we'll first calculate the distance between the center of the circle, which is origin, and the straight line. That will be the distance from origin to that straight line. That we can calculate by just substituting this formula. That will be equal to, because x1 is 0 and y1 is 0 because the center of the first circle is origin. This will be modulus of 5 root 5 divided by square root of 4 plus 1. This is equal to 5 root 5 by square root of 5 which is 5. This is the distance of origin from the straight line. This is greater than the radius of the first circle which is 4. So this line is lying outside the circle. So the distance between the minimum distance between the circle and the straight line A is equal to 5 minus 4 which is equal to 1. The second distance is between the 2 circles. So between the 2 circles it will be, you have 2 circles something like this. This is the first circle and this is the second circle. Origin is the center of the first circle. and 6, 8 is the center of the second circle. If you connect both of these points, the distance can be easily calculated. That is square root of distance between the centers is square root of 6 square plus 8 square, which is equal to 10. So this is equal to 10. What we are required to calculate is the maximum distance between the curves. So if you are looking for the maximum distance, it will be 2 points which are lying on opposite ends of each of the centers. The radius is the same. This is 4 and this is also equal to 4. So the overall maximum distance between any 2 points which lie on these 2 circles is 4 plus 10 plus 4. So the value of B is equal to 18. When we are calculating the value of C, we need to calculate the distance between the center of the second circle and the straight line. The center of the second circle is 6, 8 and we have the equation of the straight line. So let us try to calculate the distance between the center of the second circle and the straight line. That will be equal to modulus of the value of A is 2 into 6 minus Y. So this is minus 8 minus 5 root 5 divided by square root of 4 plus 1. This is the distance between 6, 8 and the straight line. So this is equal to 4 minus 5 root 5. 5 root 5 is greater than 4. So this is equal to 5 root 5 minus 4 divided by square root of 5. This is equal to 5 minus 4 by square root of 5. What is the radius of the second circle? That is equal to 4. Square root of 5 is approximately equal to 2.2. So 4 divided by 2.2 is approximately equal to 1.8. So 5 minus 4 by square root of 5 is approximately equal to 3.2. This is less than the radius of the second circle. What we are essentially saying is that if you have a circle and if you are calculating the distance between the center of the circle and a straight line, this distance is less than the radius of the circle. This would imply that this straight line is actually intersecting the second circle. So the minimum distance between the straight line and the circle is equal to 0 because there are 2 points of intersection. So C is equal to 0. Now if you are trying to calculate the value of A plus B plus C, that will be 1 plus 18 plus 0, which is equal to 19.